Welcome to Monday's Maths. Right, we're moving on to a new topic this week. We are going to be jumping a chapter, and the reason for that is because the next chapter in your Maths No Problem is geometry, and to do geometry you need to use angle measurers, and it's quite a tricky thing to do. It's a skill to learn. And we didn't really think that it was fair to ask you to do it at home. And obviously, if for those of you who've got parents who are trying desperately to do their work as well at the same time, you wouldn't be able to get the help that you need. So we've skipped over that topic, that unit, and we'll come back to that next week when we're in school again. So because we've skipped over that, there are a few bits and pieces that we're going to need to go over, because each chapter does follow on quite nicely from the one before, and it uses things that you've already learned. So there are a few things that we're just going to need to go over, but these are actually things that you've done in the past. So it's no new learning, it's just making sure that we understand it and we're revising it, we're recapping it. Before we do that, I want to just remind you of what you have already learned about position and movement. Now, this is what you would normally have done in year 4, but we actually did this with you because this was after the first lockdown. You came back in September, and this was part of the work that you did with us in the autumn term. So I know that you've done it, but I'm going to remind you of it because it will follow on nicely. What we're doing today will follow on nicely from it. So key things that we need to remember for this lesson. We've learned a little bit about coordinates. Now, a key thing to remember, really, really important thing to remember about coordinates is that we have either numbers and letters, or we have numbers, two sets of numbers or two sets of letters. In this instance, it's given us two sets of numbers, okay? And when we come across a coordinates grid like this, often it will be numbers, okay? On things like maps, you'll come across numbers and letters, but for now, we're thinking about just numbers. So we need to be really careful about the order in which we look at those numbers. That's really, really important. So this lesson that we did in September, it reminded us of that importance. It reminded us to think about which one goes first, okay? So let's just quickly recap this lesson, and I won't take too long on this. You can go back over it and have another look at it if you want to on the video. So it says point P is how many units from the y-axis. Now, each one of these squares is a unit, whether you go across it or you go up or down it, okay? So it's saying point P, here's point P, is how many units from the y-axis. Now, when we're thinking about coordinates, just like graphs, we did graphs not that long ago, we think about the y-axis and the x-axis. And just as graphs are, the x-axis always goes across. And we talked about the fact that x is across, and it goes across. So that's a really good way of remembering it, okay? And then I know that some of you will have ways to remember the y as well. I expect you're shouting at me now saying, oh, if you can remember the y by thinking about this. But I think as long as you remember y is across, you'll always know that, x is across, you'll always remember that y is the vertical axis. So point P is how many units from the y-axis. Now, you might be thinking, those of you who remember about coordinates might be thinking, but x comes first, the x coordinate comes first. It does. So watch carefully to see why it says the y-axis first. So point P is how many units from the y-axis. So here's my point P, here's my y-axis. So I'm going to count across 1, 2. So in that box there, you obviously aren't going to do this because this is previous work, but in that box there would be a 2. And then point P is how many from the x-axis. Here's my x-axis, and I'm going to count how many up. 1, 2, 3. Notice how when I count, I start here, this is 0, and I land on where the lines cross. That's really important. So that's 1 unit away, that's 2, and that's 3, okay? So point P is at 2, 3. So that's why it's in that order. I need the 2 in here, and I need my 3 in here. Okay, so this, if I look at it, this is where it is, look, on the x. I'll put a little dot there to show. This is my x coordinate, because it's that far away from the y-axis. So it might seem confusing saying, but I'm doing y first. You're not. You're actually working out where it is on the x-axis, because you're saying how far away from this line is it? Okay, how far away from 0 have we gone? And then the y-axis, the coordinate on the y-axis is 3. Look, we go 1, 2, 3 up. So it's there. So what I've done is I've gone up there and I've gone across there, and that's the point at which I'm going to plot it. Okay, if I look at Q, Q is here, look, here on the x-axis and here on the y-axis. So I'm going to say how many away? 1, 2, 3, 4 away. And how many up? 4 up. So the coordinates for Q would be 4, 4. The coordinates for S, look, if I follow that line down, I could put a little mark here. And if I follow it across, I can put a little mark here. I'm thinking about how far away from the y-axis. So I start on the y and I move away from the y-axis. So it's 8. And then how many away from the x-axis? 5. So the coordinates for S would be 8, 5. Okay? So let's just very quickly, I'm not going to do all of these, but very quickly, let's have a look to see if we can plot figure A, B, C. Now, when it says figure A, B, C, just a reminder, let's just quickly pop a little shape on there. Okay. Oh, no, that's not what I want. Bear with me. There we go. Okay. So if I had shape A, B, C, I might have A in this corner. We'll talk about that in a moment. It's not really a corner, is it? Hopefully you're saying to me, no, this is all it's not. It is a... We'll talk about what it actually is called in a moment. Okay, so we've got A, B, and C. So we're thinking about plotting. Hopefully you can work out what kind of a shape it will be. It's going to have to be a triangle, isn't it? A is at 1, 1. So let's quickly mark 1 from the y-axis and 1 up. So there's A. B is 5, 1. So 5, go along the corridor and then up the stairs. So it's 5, 1. So I'm going to put it there. And then C is 4, 5. So I go 4, 5. So actually, this has created it isn't an equilateral triangle, okay? It's a different type of triangle. So we'll cover triangles properly later. Right, so that was a whistle-stop tour of your what you did in year 4, or you actually did in year 5. Okay, let's have a look. So this I've already done with you in the Zoom call, but just in case you weren't on the Zoom call, or for a recap, I've put it onto here as well, and we'll go through it quickly now. If you feel like you've understood it from the Zoom call and you don't need to go over it again, feel free to whistle through the video until you can see that I've finished on these slides and we're on to the next one, okay? If you didn't join us, if you weren't able to be there on the Zoom call, or you didn't understand it and you want to go through it again, lots of you will probably benefit from going through it again because you haven't had that much time on shape. Then please stay with me. I'm not going to spend too long though. So key things to remember. I have put a shape mat onto Tapestry because for our coordinates work, it's going to refer to some different shapes. So some pentagons, rhombus, hexagon, kite, and so on. So you are going to need to know what we're talking about. So I've put a shape mat on there. Another key fact is that 2D shapes are also called polygons. So if you come across that word polygons, it obviously means a shape, a 2D shape. Now, the really important part is that you actually understand the properties. So let's quickly go over that again for those of you who want a recap or haven't been through this so far with me. So we've got some different shapes here now. I've actually ordered them from the smallest number of sides to the largest number of sides as it goes through the slides. So a circle, there's only one side. It's a never-ending side, the circle, and therefore it has no corners. Now, we really don't use that word. We can use it for a circle, but when it comes onto the other shapes, we would use the word vertices. So that when I was talking about this here just now and I said corners, and I said, oh, I shouldn't really use that. What I should have used is the word vertices. So vertices is the corners on a shape. And obviously a circle, it doesn't have any joins at all. There's no joins because it's only one continuous line, and therefore it's not going to have any vertices. If we look at a triangle, I've just picked an equilateral triangle, but you know there are different types of triangles. The thing to remember with a triangle is that they don't always have the same length sides. They don't always have equal angles. And we haven't talked about angles yet, because obviously we're going to go over that in geometry. But the distance between the lines, where the lines join, that's our angles, isn't it? And that's not always the same. In an equilateral triangle they are, but they aren't always in all triangles. But key things to remember, obviously, that there are 3 vertices, 1, 2, and 3, and there are 3 sides, 1, 2, 3. So that's how we often mark our vertices and our sides. A rectangle, key thing to remember with a rectangle is it's got 4 sides, and it's really important to remember that 2 sides are the same and the other 2 sides are the same. So you'll have 2 longer sides, 2 shorter sides. It might not be in that direction, it might be in a different direction. And the other thing to remember is that it has got parallel sides. So remember, that's when we're thinking about train tracks, all right, where the lines will never ever meet. So these are parallel, so I've put 2 of those arrows, and I'll just put 1 arrow on this one and this one to show that these match. So when you see a symbol and they match, that means that if they're arrows, little arrows like that, that means it's parallel. Right, quickly whizzing on through them. Now, these are the trickier shapes. So trapezium. An important thing to remember about a trapezium, and again, I have put some information on Tapestry of the properties of these shapes, just to help you, and maybe even your parents who probably talked about the properties of shape a long time ago and might just want a little recap. We've put the properties on there for you. But the key thing to remember with a trapezium is that you will have 1 set of parallel lines. Might not be the top and the bottom. It might be over the sides, so it might be so that it's turned around, and you will have 1 longer side, 1 shorter side, and 2 sides that are the same length. Okay, so trapezium, 2 sides of the same length and 1 set of parallel lines, and then you've got 4 vertices, and that makes it part of a group of shapes which are called, can you tell me? 4-sided shapes are called quadrilaterals. Good, well done. So this is a type of quadrilateral, just like a rectangle is a quadrilateral because it's got 4 sides, because quad means 4. Okay, parallelogram. This is one that some people get confused by. Basically, I want you to remember that a parallelogram is a rectangle that's been pushed over. So it's been sitting and then someone's come along and taken that rectangle and gone and pushed one of the corners, and it's gone like that. Okay, so it's a parallelogram is a rectangle that's been pushed over. So you're going to have 2 sets of parallel sides. There's 1 there and 1 there, so those 2 match, and these 2 match. Okay, and I've marked on here 3 centimeters and 4 centimeters to remind you that the sides are not the same length. These 2 sides, the top and the bottom, will be the same, and these 2 sides will be the same. Right, a kite, 2 lines of equal length there, and another set of lines of equal length. Okay, I haven't marked those very clearly, but just to say these 2 will be the same, and these 2 will be the same. So the lines that meet, they're of equal length. I'm sorry I'm rattling through this, but hopefully you've been on the Zoom call and you've already talked about it. Okay, a rhombus. A rhombus tends to get pushed about a bit as well. I've said that because a rhombus is basically a pushed over square. Okay, and in order to demonstrate that for you, I'm actually going to show you. Let me just quickly screen share. Here we go. You can have a little play around with this. Again, I'll save this onto the Tapestry post if you'd like to have a little go at it. So down here, you can see that this allows you to have a little play about with a rhombus. So if I move 1 side, it moves all the other points for me. But basically, if I mark on the side, you can see they're 150, and the angles, these two angles are the same, these two angles are the same. Watch what happens. Can you see? Opposite angles always stay the same, and the length of the sides never ever change. So that's how we know that we've got a rhombus. Okay, right, let's quickly go back to our other screen. Right, okay. Let me go back. There we go. Right, square. I know you know about squares. All the same length sides, 4 vertices, and they're all right angles. So basically, a rhombus is one of these, and it's been one of the corners or one of the vertices has been pushed, and it just goes slopes to the side. Pentagon. Don't be fooled. Pentagons don't always look like this. They can be irregular pentagons as well. But we need to remember that a pentagon is any 5-sided shape. Any 5-sided shape. And because it's got 5 sides, it's also got 5 vertices. Same with the hexagon. It's a 6-sided shape. Any 6-sided shape. It doesn't have to look like this. This is a regular one. Irregular ones don't look like this. So 6 sides, 6 vertices. Heptagon is 7 sides, 7 vertices. Octagon is 8 sides and 8 vertices. Nonagon is 9 and decagon is 10. I haven't put those on there, but that's for you to remember. Now, quickly having a look back at trapeziums. This demonstrates the different types of trapeziums you might come across. So you might have the long side on top and the shorter side on the bottom. It might not look anything like that, okay? So that doesn't look anything like that one, but it is. Okay, so we've got opposite sides are parallel. This one here, not a trapezium because it's a 5-sided shape. Okay, this is a rhombus, right? Am I right? Yeah, it's got to be a rhombus, isn't it? It's not. Yeah. Is it a rhombus? I'm really hoping you're saying, no, Mrs. Hall, it is not a rhombus. I'm really hoping that you're saying to me, no, Mrs. Hall, it's actually a square. And all we've done is I've turned it, and that often fools people. They look at that shape and go, oh yeah, it's a rhombus or it's a kite. No, it's not. It's a square. Turn your head or turn the paper, and that will help you, okay? So same with my trapezium here. Look, I can rotate it, and it can be any angle at all, and it is still a trapezium. It doesn't change my shape. There's some more examples of some rhombus. And then we've talked about vertices. Right, quickly, lines of symmetry. Lines of symmetry we have talked about before, obviously, but lines of symmetry where we would draw a line down the middle and it's the same on both sides. So if I had this shape, I could cut this shape out, and if I folded it down this line, they would meet exactly. Both points would meet exactly, and that's the same for all of these, okay? And then some shapes have more than one line of symmetry. So I've put some here, look. These have more than one line of symmetry. If I cut that shape out and I folded it anywhere along any of those lines, it would fold exactly in half and all the vertices would meet. Right, okay, whistle, 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 stop tour. So, hi, if you are back with us because you skipped on through. So let's have a look at lesson 1. This is now the year 5 curriculum we're back to. So this is the in focus that you will find in your book. Naming and plotting points. Right, so you need to make sure, please, that you put today's date in your squared paper book, which is 1.3. Yay, we're in March. I love it. Okay, so it says A, B, and C are vertices. So we know what vertices are. They're the corners of our shape. Vertices of a polygon. We know that polygon is a 2-sided shape, 2D shape, sorry. So A, B, and C are vertices of a polygon with sides of equal lengths. So you need to find the possible positions of the other vertices. Now, I'm going to draw your attention to something that they've done here. Look really, really carefully at what they've done with point C and point A. just going to draw that line down there. I don't want to tell you any more, but think very carefully about what that would be. Now, there's more than one solution to this, so be really careful to try and have a look and see different solutions. So there's 3 of the vertices. I don't want you just joining up that line. That's not what it's asking, okay? It's saying that that's 3 of the points, 3 of the vertices of a polygon, but that's not all of them. So you need to decide how could you plot some more coordinates to create a polygon which has got sides which are all equal lengths. So off you go, have a little play around with that. You can use the squares in your book. Okay, so if you want to draw this, you can use the squares in your book, or I've actually put some grids for you on Tapestry, which you can obviously print off and have a go at as well if you'd like to, whichever you find easiest. Okay, if you're doing squares in your book, don't forget you're going to need to kind of imagine where halfway across the squares are. Right, off you go. Right, okay, let's have a little look at our let's learn then. Okay, so we know that in order to find a coordinate, we have to go how many units away from the y and how many units away from the x. So B is 3 units away from the y-axis, and it is 6 units, 1, 2, 3, 4, 5, 6. It's 6 units from the x-axis, which means that it is along the corridor 3, up the stairs 6. So I'd write it as 3, 6. So it's really important that you remember that you put it in brackets, you put your x coordinate first, then a comma, then your y coordinate, and then a bracket. So that's what coordinates looks like. That's what we should see. Okay. So let's have a look to see if we can figure out how we might make a vertex, make a polygon. So clearly said, sorry, I'm just having a quick look at this. Yeah, so that's a bit different because it's talking about B is there, sorry. So now we're looking at these ones that I said were a bit strange, A and C. So let's have a quick look at those then. So A, so this was the simpler one because it was on the point where the lines cross, but A is a bit trickier because it's halfway across. But you don't treat it any differently, and we've talked about fractions, so we know about halves. So we're going to say how far away from the y-axis is it? 1, 2, 3, 4, and then half again. Hasn't made it all the way to 5, so it's 4.5, and then up 8. So my coordinate would be 4.5, comma 8. Yeah, I've gone across 4.5 and I've gone up 8. Sorry, I had a brain block for a moment there. And then the same with C. C is in line vertically with A. So again, we're going across 4.5, but this time we're only going up 4. So it's 4.5, 4. Okay, have a good look at that to make sure that you understand it. Pause the video if you want to really carefully look at that. Right, okay, so let's have a quick think about quadrilateral. Right, it says A, B, C, D is a quadrilateral. So we know that it's going to be a 4-sided shape. Good. So where would that point be? Now we know that the key thing, one of the key bits of information that we've been told is that each of the sides is the same length. So we need to think really carefully about how long these are. Right, now I'm going to show you what it is and then I'm going to talk you through how they did it. Right, this is the point that they've done it at. Okay. Now, you might say that's a square, but actually it's not a square. I would say that that is a rhombus because these aren't right angles. Now, let's have a look to see the easiest way that we might be able to work it out, okay? So we have got 4.5, 4 for point C, okay? We have got 3, 6 for point B, and we've got 4.5, 8 for point A. So we're trying to figure out, well, how did we know that we would go to 6, 6 for point D? Right, well, let's have a think about the fact that there must be a line of symmetry here because we know that this line has got to be the same length as this line and this line and this line. So if there were a little dotted line down here, let's quickly put that in. I'm just going to do a normal straight line actually, but I'll do it in a different colour. No, I won't do it in a different colour. Let's try that again. I'm definitely clicking on the right thing here. Don't know why it's not coming up. Red. Try once more. Okay, not to worry. You know that this is what I'm talking about. So here, if I were to go down 2 and across half and another 1, so 1.5, I get to point B. So in order to get to point D, I know that I've got to go down 2 and across 1.5. So half and then 1 more takes me to point D here. Okay, let's practice that again. Let's have a look at the next one and see. Right, A, B, C, D, E, F is a hexagon. We know it must be because it's A, B, C, D, E, and F, 6 points. And we know that if it's got 6 coordinates, it's got to have 6 vertices, which means it's got to be a hexagon. We know that this is going to be a regular hexagon because we've been told already that all of the points are of equal, sorry, all of the lines are equal. Right, so thinking about what we've done, we know that we've got this here, and I'm giving you a bit of a clue here. We know that we have got this here already. I know that this has got to be an equal length. However, I can't go from A and go, oh, I did this far. So let's have a little think about how we might work out that we've got to put this at point F, put this at point E, put point D here, and so on. So let's have a little think about it. Okay. Right, let's have a look. So I know that I've got to make these the same length. Well, if I were to just stop it here, I could tell, definitely tell, couldn't I, that this line would not be as long as this line here. So you can actually have a look at it really carefully and see if you can make a judgment, okay, as to where you think that point would go. Also, we can imagine where our line of symmetry would be. So if I put a line of symmetry across here, that means that my point E has got to be along this line, hasn't it? I know that point F has got to be along here because it's got to be in line with A. And I know that D has got to be in line with C. Okay, so that's key things to think about. And then let's just quickly show you, if I were to put one here, that would, all of them would have to be half less. Let's have a little look, see what that would look like. Okay, does that look right? It doesn't, does it? You can see that this line is too short in comparison to this line here. So that's key things that you can have a think about. Okay, it says here, label the other vertices. What would the other vertices be? Okay, so let's have a quick look at your guided practice together. It's got P, Q, R, S, T, U, V, W is a polygon. P, Q, R, S, T, U, V, W. What shape is my polygon going to be if it has got that number of coordinates? I'm not going to tell you. I want you to think about it. There's our polygon anyway, you can see it, but we know from the fact that it's given us that number of coordinates, we know what our shape is going to be, what our polygon will be. So first thing you've got to do is write the coordinates of Q and think about how far from Y and how far from X, then R, then T. And then it tells you where, or can't remember her name. She said that S is at 6, 6.5. Is she correct? You have to say why or why not. And then, is it a regular polygon? Think about what regular means. I've talked about that quite a lot for you. Okay. Second sheet, it's another type of quadrilateral with exactly one line of symmetry, no more, exactly one line of symmetry. It says the sides cannot all have the same length. And then there's some statements here from our kiddies, and you have to decide who has got the correct statement. So again, there are some of these grids saved, so you can have a go at drawing them and drawing the different points and seeing where they are and seeing, does it match the properties that you've been given? So have a think about where D would be for, that's not Elliot, is it? I can't remember his name. But think about where the point would be, the coordinate would be for him, and then each of these different children. Okay, right. Workbook, you're doing something similar. All right, you're writing the coordinates. Then you're thinking about what type of quadrilaterals they are here, which is why I've gone over the quadrilaterals. So you're going to plot them, and you're going to decide what the quadrilateral, what's the name of the quadrilateral for that one. Okay, if you manage to get through all of that and you've still got a bit of time left, I've put 2 levels of some more practicing, plotting missing coordinates, missing coordinates, and then drawing them and having a go at checking that you've actually got it. So there's 2 levels of those. Okay, don't be fooled, they are different. So you look at them, go the parallelogram, trapezium, and kite, but they're 2 different levels. Right, I have waffled on for long enough, so I'm going to let you get on. And if you have any problems with any of it, let us know, because it's really helpful for us to know quite quickly so we can help you with it. And then obviously we can try and add some extra things into our Zoom call the following day to try and support you with your maths. So I hope it goes really well, guys.